Not too long ago I put out this video, and in that video we looked at some alternative or non-traditional avenues for you to explore to find that bespoke flight controller or peripheral that you're looking for. And one thing you will have noticed is many of them are 3D printed. So the question is this 3D printed components a real thing? Is it something that's practical? Well, to find out, I teamed up with a company that I consider a leader in the field, and that is Authentikit. For those of you that have followed my channel for some time will be aware that I've featured Authentikit products previously, and in fact I've done a number of videos on that, and I'll leave links to these in the notes below. I'm some way down the line to completing my Spitfire Mark 9 cockpit. So I invite you to join me and Phil, the man behind Authentikit, as we take you on a journey from the first visit to the website all the way through to holding the product in your hand. And along the way, we're going to unravel the mysteries of 3D printed and 3D printed components. So come and join me and let's get the full Authentikit experience. Welcome to the SimHanger. My name's Mark. Thanks for watching and let's get started.
Authentikit is a freeware project. We're creating flight controls for a wide range of aircraft with an initial focus on vintage warbirds, followed by vintage and classic general aviation. We're harnessing the power of 3D printing in conjunction with high quality but low cost components like Hall sensors and sealed bearings. All flight controls can be assembled at your kitchen table with no workshop tools, no soldering and no metal work. You can source the parts yourself, or third parties are providing kits of all the hardware as well as 3D printed parts.
Our journey starts by a visit to their website, and there's a wealth of information available. I'm not going to go into minute detail, I've done that in my previous videos, and we'll cover more later on. As Phil has already mentioned, Authentikit is freeware. That is to say, the designs, bill of materials, and associated information is available free of charge. There'll obviously be a cost to sourcing the raw materials if you are 3D printing, purchasing the hardware kits, or buying the 3D printed components. The products have been cleverly designed. You don't need to be an engineer to assemble them. And there's assembly guidance videos online to assist in that regard. But if you are interested in jumping into the 3D printing world, there's some advice and guidance there as well. 3D printing or not, you'll require some hardware, and Authentikit have teamed up with SimKit Supplies, who can provide this to you in kit form. And you can purchase a kit more or less specifically for the peripheral that you want to assemble. But if 3D printing's not for you, from SimKit Supplies you can also order the complete kit, including the 3D printed parts. And in this way, Authentikit's able to cater to meet all requirements. In terms of pricing, Authentikit will give you ballpark figures of what it should cost you, depending on where you're sourcing, of course. Detailed pricing available via SimKit Supplies. Let's move on. Back to the Authentikit homepage. I'm going to select products. It's mainly warbirds at the moment, others in development. Now I'm looking for the Spitfire Mark 9, which is right at the top. So I'm going to select that, and it takes us to a page which covers everything available for the Spitfire Mark 9. And today we're particularly interested in the elevator trim wheel. We'll use that as an example and follow it through. They have a fairly extensive range for this aircraft, including spade grip, throttle quadrant, rudder and elevator trim, flaps lever and more. And it tells us we need kit B for the trims. Each kit may cover a variety of product. As mentioned, we're interested in the elevator trim wheel, the one in the center. So the next step is to download the files. And this will include all the information that we're going to require for that particular component. There it is, download files, select that. And that's correct, the Spitfire Mark 9 add-on kit B. So I can add an elevator trim to my Flying Iron Spitfire Mark 9. Click download and it's done. The download is in the form of a zip file. The file we just downloaded is in my downloads directory. I'm just going to cut and paste this elsewhere on my PC so I have it for future reference. I don't run or unzip files in my download directory because I'll end up deleting it. That's now saved elsewhere, so let's unzip the file. I'm using the default 7-zip in Windows. And the file is now unzipping, and as we can see, the information supplied is comprehensive, from bill of materials to 3D print files, as well as a selection of useful and essential PDFs. I'm particularly interested in the directory Spitfire Mark 9 trim wheels, so let's open that, and it contains information for both rudder and elevator trims. I'm interested in the elevator trim, their STL files, so I can view them in the default Windows 3D viewer. Double-click the file and the 3D viewer opens, and I'm able to view each component individually, but all looks good this end. It has certainly downloaded correctly, and this is the actual trim wheel itself. Let's just have another quick look at another component. I'm going to use the trim wheel cap. Have a look at that, and once again that all looks correct. In the 3D viewer, of course, you're only getting a graphical representation of the file. For 3D printing purposes, well, you need something more. So let's have a quick look at that. The software that we use for 3D printing will very much depend on what sort of 3D printer that you've got. For starting off, Authentikit recommend the Seriality Ender 3 V2. And I must say, I'm no expert on 3D printing, but this sort of technology is not as expensive as I thought it would be. This 3D printer, for example, which is designed for personal use, £209. And from what I can gather, it's a fairly popular one in the market. So in terms of software selection, we're going to assume we're using the Seriality Ender 3 V2. In this instance, the software we're going to use is the Ultimaker Cura 5. And as an added bonus, it's freeware as well, although you may need to register. And of course, I will leave all links in the description notes below the video. So let's go ahead and download that. We select download for free. You get an option for which operating system. Mine is obviously the Windows version. And the download starts. And once again, it will download as a zip file into your downloads folder. As I did previously, I've cut and pasted it elsewhere on my PC, just a personal preference to not run it from the downloads folder. There it is. It's got the Windows Shield on, but I'm going to select Run as Administrator just to be safe. And the install should start. Yes, I'll authorize the app on my PC. And now the installation should start. Here we go. And the install is a fairly standard application install process. Accept the agreement. I'm going to change the directory where I'm going to install this. I don't want this on my boot drive. I'm going to select the same directory to which I put the zip file and the install file, which I've called Cura5_1 as its version 5.1. Change the directory, that's done, and let's go ahead and install. The install doesn't take too long. We're almost done now. And once it's installed, we'll run the program. There we are, it's done. I'm going to select Finish, and I'll leave Run Program tick enabled. Let's have a look what we got. Program takes a few moments to load all the various components of the program. And we're into Ultimaker Cura 5.1. As mentioned earlier, I'm no 3D printing expert, and I won't pretend to understand all the elements of this particular program. I leave that to the more technically inclined, such as Phil. Now, Phil has a printer and I don't, but what I can do is give him a file for 3D printing for the elevator trim wheel. To do that, all I need to do is go and find the STL file or files, select them and drag and drop them into the Cura 5 software. I'm going to select the elevator trim wheel, drop it into Cura 5, and there it is. We're going to select this one as our high resolution print. For me to send this file to Phil, I need to click on Slice, but first a few simple steps before I do that. Firstly, I've got to make sure that the file is in the correct format by choosing the correct printer. I'm going to select a non-network printer, and it certainly seems there's no shortage of 3D printers in the world. There's hundreds or possibly thousands of them. Remember, we're using the Seriality Ender 3. There it is, I've selected that. We get a summary of the machine settings. Click Next and that's done. We wouldn't want to print the wheel in this position. Probably be a failed print if we tried, so I'm going to change it from vertical to horizontal. I clicked on the image to get the visual representation of the various axes, and I've rotated 90 degrees to the left. The trim wheel is now laying flat on the ender deck, so now I can go ahead and select slice and generate the file. Only takes a few seconds, and I'm going to opt to save this to disk, so I retain a copy. I'm going to save it in the same directory that I installed the Cura 5.1 in. From the drop-down menu, select G-code, which is the file format we require. Click Save, and we're done. We get the option to open the folder, which is what I want to do. Elevator trimwheel.gcode, there it is. I'll make a copy to my micro SD card and send it on to Phil. Phil, over to you.
Okay, thanks Mark. Here is the SD card, and I'm going to pop it into my Creality printer right now. Now for the keen-eyed, you may notice that this printer is actually an Ender 6, an SE version, but it's very, very similar to the Ender 3 version 2, and it will print the same G-code that Mark has prepared for me. So, pop in the SD card, and for some strange reason you have to hold them upside down, so pop them in that way round. In it goes. Hear that click into place, very good. And then we power it on. There we go, you can see the navigation menu there showing the startup bar. Now let me just tell you a couple of things about 3D printers while I'm here. This is the print bed, and the very first thin layer, it's only about 0.1 millimeters high, is printed by squishing, I'm sure that's the technical term, squishing heated filament onto this so that it sticks. The filament is heated by a nozzle that's underneath there. Best not to touch it, it does get pretty hot. And actually the bed itself, this is called the bed, this also gets warm too, about 50 Celsius typically. So the first thing the printer will do is to warm up the nozzle and the bed. It takes a good couple of minutes for that. Once that's done, a little motor up here pulls the filament, that's the black stuff here, out of that box where there's a reel of filament, pushes it then through the nozzle and out onto the bed. Now filament costs about $20 or £20, so it's not at all expensive. There's a kilogram in that box, which is enough for a lot actually. Enough for most of a Spitfire cockpit in fact. And the box it's in, you don't need that really, that's something I've got as an extra. It heats the filament and it also drives out moisture. In fact you can see there's a sort of condensation on the inside because this filament can accumulate moisture. You don't need it, as I said, but it can improve print quality. Okay, let's get printing. The navigation on the menu here is very similar on my Ender 6 as you will find on an Ender 3. So I just hit print, and then if I scroll down the list, I've got some test prints in here. That is the elevator trim G-code that Mark prepared. You get a little prefix at the start which tells you which printer it's been prepared for. And it doesn't have much space, so it always does these squiggly things at the end. So I just hit print on that, and the print process has begun. Now it does take a couple of minutes, as I said, and I'll just tell you what will happen shortly, and that is there are a couple of preliminary steps that happen, and they vary a little bit according to the printer. So on my printer, for example, this print head, it'll move to the middle, and it'll do a kind of touchdown. And it kind of does that just to help calibrate the exact vertical offset that it needs to put things at just the right place. The second thing it does, and this is fairly typical, is that it does a kind of line on the left. Some printers do it on the bottom, and you can kind of configure it. And the line is a kind of, well, it's a wipe process. It just kind of cleans off any bit of filament that you've got sticking around on the end of the nozzle from previously. So just to talk you through what's been happening while I've been talking, it's been heating things up. So down here we can see that the bed is at 45 Celsius now, and it is targeting 55 Celsius before it can move on. And when it reaches that, it'll now heat the nozzle up. So let's come back to that in a second. Okay, we're nearly ready. That's about to hit 55 Celsius. There it is. And the temperature we're going to print the nozzle at, the filament at, is 215 Celsius, so it's pretty hot. I said don't touch it. That heats up quite quickly because the nozzle is just a tiny piece of metal. Okay, drum roll, things are about to happen. Okay, here we go. that's the touchdown I spoke about. And what it tends to do, actually, it ends up leaving a little blob. You can just about see it. I'm going to scrape that off. I like to do that in case the print goes there. So it's just a little blob of filament. And there's the white process, so it's just cleaning off the nozzle now. And I don't know if you can pick up, but just in the last 30 seconds or so, it's got a little bit louder. There's another fan switched on. That's really all the sound you get from this thing. It's just the sound of the fan. So there's a fan in here that cools down the filament as it comes out of the nozzle, and then a fan in here just for the power supply. And that's really all the sound that you get from these. And this is it. The process is underway. That's the first sort of outer diameter circle of the elevator trim wheel, so you can sort of see what its footprint will be now. And there are these interesting little circular bits that run around the edge of it, and then there's a second inner filament being drawn. These are 0.4 millimeters wide, by the way, so it's really fine detail. And you'll see as it completes that, it'll draw another ring just next to the one that it's drawn before. And the two will basically join up. So you'll start to get effectively a sheet, a 0.1 mil, well, slightly thicker, but 0.1 millimeter thick sheet of first layer going down on this trim wheel. Okay, well that looks underway. It's always a good thing just to watch that first layer happen, just in case, I don't know, you ended up with a bit of grease or something on the print bed and something isn't sticking properly, but that looks absolutely fine. So let's leave that printing and we'll come back to it in a little while. So it's been printing a little while now, and I will talk more later about how long it takes to do 3D printing. But for now, let's just see how things are looking. You can see that that initial outer ring is building up into a circular wall, and it's about 5 mil high right now. And also when we stopped the camera before, we hadn't started on this inner mounting post. So that's also building up at the same time. Now the shape of that post is actually a bit like a cone. It's getting wider as it goes higher, and pretty soon it will actually join the outside so that the whole thing becomes one single piece. The other thing that's pretty obvious is that this is not solid. Inside the shell is a kind of honeycomb pattern, and that's the reason you can print so much with just 1 kilogram of filament. You get to choose how solid you want it in the Cura slicing software. I have to say that when you first get a 3D printer, it can be quite captivating watching these engineering quality objects growing before your very eyes. The nozzle, as I said, it's only 0.4 millimeters wide. It's very, very tiny, so the precision is quite staggering for something you're making in your spare room or study. Anyway, let's leave it printing for a little bit longer. In fact, when I come back to this next, it will be finished, and we'll see what the completed item looks like. And here we are. Honestly, this is the first time I have touched this since it finished a few hours ago. I'll just bring the print bed forward. The print bed is now down to room temperature, so it's just cooled down. You can hear the fan going. That's the fan up here, and that's still sort of whirring away until I power off. So I'll just power everything off. And now that the bed has cooled, it simply releases the part that's on it. So the stickiness that was there that was needed for printing is gone, and I should be able to just pick it off, just like that. The tiniest sound as it released. So that's it. There's really no more preparation needed, or clean up. Some people like to kind of sand it down and do some fancy sort of painting. I don't do that. I think it looks fantastic as it is. There is actually one small thing that this particular design needs. It's these little tabs. You just sort of tear these off. It's kind of Airfix style. But that's actually very unusual. I added them to stop that mounting piece sort of wobbling as it was being printed until it connected to the outside and made into one piece. But 99% of the time, you don't need these tear-off tabs or any sort of cleanup. So that is our elevator trim wheel, ready for Mark to complete his build. Now, when you make one of these for yourself for the first time, I challenge you not to be impressed. I mean, I still am. It's not a flimsy sort of plasticky thing that feels like it belongs in a toy box. It looks and feels like a properly engineered part that you might cost you some serious money. Anyway, before I get carried away, I'll hand you back to Mark in a second, but I did just want to talk about timing. 3D printing is not quick. This trim wheel will take between 6 and 12 hours, depending on the settings you use in Cura. It's a trade-off between strength, fine detail and speed. What I tend to do then is print overnight, and also I rarely print just one item. When you download the files from Authentikit, as well as having the individual STL files, and if you recall there was one file for this print wheel, there are also files which have batches, multiple prints all in one go. So I'll just put on screen an example of that. So if you just leave this print batch going for about a day, all these items will be printed in one go. So that's the trade-off, folks. Print your own, and certainly if you're going to make a few items, you'll find it's a pretty cheap option. Get someone to do it for you, and it does take time, and that's where some cost can come in. Anyway, that is my part done. There you go, Mark. One elevator trim wheel for a Spitfire Mark 9.
Hey, thanks Phil. Well, I've now received the trim wheel along with all the other components required for assembly, which includes my SKS kit. So I'm now ready to assemble the trim wheel. What follows are just a few short extracts from my assembly. If you'd like to see more detail, then check out this video, once again link in the notes below. Or if you want a detailed step-by-step guide, the Authentikit video will be linked below as well. I've included elements of the assembly just to highlight how simple and straightforward the assembly is. So here's my full kit, 8 pieces of plastic and a little bit of hardware. Let's get started. We have a bearing and that will allow for the movement of the trim wheel. The plastic plug goes inside the bearing and then we fit the plastic cap on top. Everything seems to fit just right. And what we're doing is assembling the heart of the unit here. Authentikit boasts that no soldering will be required in assembly, and we're about to put that to the test. Once assembled, make sure these center pivots still can rotate. We've got 3 cables, yellow, green and black. According to the instructions, we're going to start off with the yellow cable, and I've just taken a little bit of the insulation off the very end. And as you can see, it's holding that yellow cable nice and firmly. We repeat the process for the black and for the green cable. And here we have all 3 connected. Just make sure there's no loose strands causing a short. And now to put our assembly into the main unit of the trim. A nice satisfying click as it goes into place, and that's held fast. Push the cables out the way and time to fit the base on. And now we screw that on. There we are. That's done. Nice and simple. We're almost complete. All that's left to do is actually fit the trim wheel itself, and the trim wheel and the center pin again are deslotted. That feels good. Once that's done, a single screw will hold that in place. And then the final step is there's a small plastic cap that fits over the front of the face wheel to hide the screw. And we're done.
How does that feel? Not bad, not bad. I think a touch more. Oh yeah, that's nice.
As an individual, I'm not particularly big on the DIY, but I found the assembly process fairly straightforward, partly due to the component design only allowing you to fit things one way in many instances. My trim wheel is complete, so let's add it to my Spitfire cockpit build. I'm in the virtual cockpit of the Flying Iron Spitfire Mark 9. And looking down on the left-hand side, we can see the rudder trim, elevator trim and throttle quadrant. Turning now to my Authentikit cockpit, it's time to install the elevator trim we've just assembled. And it's just a matter of slotting it into the holder, allowing you to swap peripherals quickly and easily for different aircraft if you wanted to. Simply slide it into place and then connect the standard network cable, which in turn is connected to the central hub. And what makes the Authentikit cockpit unique is you can position your peripherals exactly where they are in the aircraft, making it perfect for VR flight but equally excellent in 2D mode. Here you can see I've got the spade grip or the flight stick. This includes the brake handle, and there's also a firing button. I have the rudder trim, Now the elevator trim and the throttle quadrant with prop and mixture as well as throttle. And in the top right hand corner you can see the hub. The hub is connected to the PC through a single USB. The hub and all Authentikit devices attached to it are recognized by Microsoft Flight Simulator in the configuration options as a single device. And of course you have to configure all the options and you can set up the sensitivities for the axis as required. Here you can see I've got the rudder and elevator trims configured, but note that they are button presses and not an axis. Configuration uses the Microsoft Flight Simulator default commands. That's the throttle, now the mixture. We can also test the prop, that's all working fine. And of course we'll test the trim wheel. And that's turning as expected. But note the rotation is not 1-to-1. And Authentikit have a solution for that as well. Available to download for free is the Authentikit Tuning App. And this very useful app allows you to adjust the sensitivities or number of repeats of button presses, so you can turn up or down the reactivity of a particular function, allowing you to get closer to the real thing. And it works great for the Honeycomb Bravo throttle quadrant as well. And yes, you guessed it, I've done a video on that. Check out this video for more details, links in the notes below. And that brings us close to our journey's end. And I hope that having been on the Authentikit journey with me, not only has it highlighted the versatility of the Authentikit peripherals and the opportunities therein, but has also helped unravel some of the mystery and perhaps suspicion surrounding 3D printed parts. Not all 3D printed products will be of good quality. It very much depends on their design to make them fit for task. But in the case of a company such as Authentikit, where you can take confidence and comfort in their level of expertise. For me, next on the agenda, well, it's the throttle quadrant for the P40B Tomahawk. Now I'll keep you updated how I get on. Thank you very much for joining me today. I hope you found this useful and informative. Stay well, look after yourself, see you again soon, and bye for now.